The ideal gas law is one of the most useful laws in chemistry. It's equal to PV equals nRT. And pressure will have to be listed in atmospheres. Volume has to be listed in liters. The number of moles must be in moles. The number of atoms have to be listed in moles, and the temperature must be in Kelvin, or the equation won't work. R is always going to be equal to 0.08206 liter atmospheres mole Kelvin. Okay? This is the only R that we'll be using in this class. And so it's another substitute in issue here. It's not too difficult. We've got dinitrogen oxide, which used in dentistry. It's an anesthetic. What pressure in atmospheres? So what we don't know is the pressure. Pressure is equal to, we're not sure. And we're told that we've got 0.350 moles. We're told that we've got a temperature of 22 degrees Celsius. We're going to have to add 273 to that to get us to Kelvin. And volume it's a 5-liter container. So this is 295 Kelvin. All right. And R, I already told you, will always be this number, 0.08206. And this is liter atmospheres moles Kelvin. So PV is equal to nRT. The one thing we don't have is the pressure. So if we'll take both of these and divide by V, we'll get P is equal to nRT divided by V. N is 0.350 moles. R is 0.082, 206. And this is liter atmospheres and mole Kelvin. And then we've got to squeeze in beside that the temperature, which is 295 Kelvin. Just barely got it in there. All right, and we're going to divide that by the volume, which is 5.00 liters. If we do our math, we take our 0.35, multiply it by 0.08206, multiply by 295, and divide by 5. We'll get 1.7. Now let's see what units we end up with. Let's see. We have a mole here, and we also have moles in our R, so that's going to cancel. We've got Kelvin here, and we've got Kelvin in our units of our R, so those cancel. We have liters down here and liters up here, so we are left with only atmospheres, which is very convenient because measuring pressure, we want it to be in atmospheres. Well, let's practice another one. This would be a very good time for you to stop the video and see if you can work this problem by yourself. Calculate the volume occupied by, so we've got a number of moles, 0.845 moles. We've got pressure, 1.37 atmospheres. And we have a temperature of 317 Kelvin. We also have R. R does not change, so R is always going to be 0.0821, and this is liter atmospheres, moles, Kelvin. All right, and we don't have the volume. That's what we're looking for. Well, PV equals nRT. We're trying to get the volume by itself. That's what we'd like to have by itself. So if we divide both sides by P, these two P's will cancel each other, and we will get V is equal to nRT divided by P. Over here, we already know what N is. N is 0.845 moles. R is 0.0821 liter atmospheres. And moles divided by moles Kelvin. This time I left room for my Kelvin. I've got 317 K. Let's divide that then by the pressure, which was 1.37 atmospheres. We do our math. We come up with, turn the page, 16. And what units are we going to end up with? Let's see. We've got moles here that cancel the moles there, and Kelvin here that cancels the Kelvin there. And we have atmospheres down here and atmospheres there. So we're left with liters. So let's try another one. Let's calculate the number of moles of gas in a basketball, inflated. And so let's write down what they've told us. We're looking for N this time. And we know that the basketball has a volume of 3.24 liters. I know that because liters is a unit of volume. We have a pressure of 1,241 millimeters of mercury. And we have a temperature of 25 degrees C. Okay, well, the 25 degrees C, we're going to have to add 273 to that, and that will give us our 298 Kelvin. But we can't have pressure in millimeters of mercury. We're going to need to convert that into atmospheres. We know that 1 atmosphere is equal to 760 millimeters of mercury. That's something that's look-upable. It's just a conversion factor. So if we start with our 1,241 millimeters of mercury, and then we use this as our conversion factor, we want 760 millimeters of mercury to be on the bottom so that that'll cancel. I did not get that very straight. There we go. And we'll put our 1 atmosphere on the top. And we get our new pressure to be 1.62 atmospheres. Okay, so now we can proceed with our problem. We know that PV is equal to nRT. We want to solve for N. We want to keep N all by itself. So I'm going to divide both sides by RT. That will make this RT will cancel with that RT and leave N all alone, which is what we're looking for. So N I'm just going to rewrite it, is equal to PV over RT. Okay, so P is 1.62 atmospheres. V is 3.24 liters. And the temperature, R, we need to put R, 0.0821. This is liter atmospheres moles Kelvin. And the temperature is 298 Kelvin. Always check your units. If you've forgotten to switch something like milliliters of mercury, it will become obvious when you set the problem up and you have a unit that doesn't cancel. So let's get up here. I want to make this a real thin line so that we can still see it after I've crossed it out. So let's cross out atmospheres. Let's cross out Kelvin. Let's cross out liters. And we're left with moles as the bottom of the bottom, and so that will bring it up to the top. And the answer to this is 0.21, and it's moles.